Hello everyone, and welcome to another video with Special Maths Academy. In this video, we'll be looking at the 13th problem from the Special Maths Contest 2023 edition, the first round. But before we dive into the video, I would like to first of all remind you to subscribe, like, share, comment. You notice that some of our viewers are not subscribers. Please subscribe, ladies and gentlemen. Okay, also I would like to wish all the prospective participants in the next edition of the Special Maths Contest, which is going to take place tomorrow, 17th of January. 2026. I'd like to wish you all a wonderful exam. I wish you success, and I hope you have fun while you smash your exam tomorrow. Okay, so let's go into the problem. It says, what is the remainder when 1 to the power of 1 plus 2 to the power of 2 plus 3 to the power of 3 plus dot 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 plus 2023 to the power of 2023 is divided by 7? Okay, so first of all, something that's important to know is the Fermat's latest theorem. Okay, so this is different from Fermat's last theorem. So if P is a prime number, and A is a member of natural numbers with the GCD of A and P being equal to 1. Then A to the power of P minus 1 is congruent to 1 mod P. Okay, so it means if we replace, of course, P is a prime number, 7 is a prime number. If we replace P with 7, means in this case, we can just say that A to the power of 6 is congruent to 1 mod 7. Okay, so given that uh, GCD of A and 7 is equals to 1. Okay. So let's look at this question. Okay, so 2023 divided by 7. This is equals to 289. Okay, so we see that 2023 is perfectly divisible by 7. So one idea would be to group this in terms of sevens. So let's write the sum like this. So 1 to the power of 1 plus 2 to the power of 2 plus 3 to the power of 3 plus 4 to the power of 4 plus 5 to the power of 5 plus 6 to the power of 6 plus 7 to the power of 7, okay, plus 8 to the power of 8, okay, and so on and so forth. So basically, we have 1 plus 7k to the power of 1 plus 7k up to 7 plus 7k to the power of 7 plus 7k. Okay, so we want to add these terms together. Okay, so something we can realize that when we take this mode 7, so I want to mode 7, let me just put mode 7 somewhere. So mode 7. So what we can realize is that when we take the congruence in mode 7, so the first column, okay, so I'll just take them column by column. So the first column simplifies to 1 to the power of 1 plus, okay, so 8, just 1 to the power of 8 plus 1 to the power of, so 8 plus 7, 15, so on and so forth. So 2023 divided minus 6, so this will be 2017. Okay? Yeah, 2017. Okay, and then the second bracket will be 2 to the power of 2 plus 2 to the power of so this is going to be 2 plus 7, that is 9, and so on and so forth. Okay, so let me scroll down a bit. So we can kind of like get the basic idea here. Okay, so basically we want to simplify the things in each of these brackets. Okay, So recall that 8 to the power of 6 is, congruent to 1 mod 7. So if you break this down, so let's see, so break this down, you have 1 to the power of 1. So recall that anything to the power of 6 is congruent to 1. So I know like 1 to the power of anything is always going to be congruent to 1. Mod 7. Okay. So 1 to the power of anything is 1 itself. So, but just to get the bigger picture, so we keep on subtracting 6. So this would be 1 to the power of, so 8 minus 6 is 2. Uh, 15 mod 6. Okay. 15 mod 6 is going to be 3. Okay, we see that it goes in this pattern of 1, 2, 3, and so on and so forth. And 2017 mode 6, that is going to be, so 6 will go into this. So 2017 divided by 6, 6 will go into 23, 2, this is going to 21, 3, remainder 3. So remainder of 1, okay? So it ends with a 1. Okay? So but let's explain why I can do this. So if you have 8 to the power of, so assuming A is relatively prime with 7. So if you have A is relatively prime with 7, okay. So since we have 8 to the power of 6 is congruent to 1 mod 7, means we have 8 to the power of m. So this is going to just be congruent to 8 to the power of m. So the remainder of m mod, so the residue of m mod 6 mod 7. Okay. So why is this true? Because we know that we can keep on, so 8 to the power of 6 times 8 to the power of n minus 6. So we can keep on like reducing the power by 6. And we know that this is congruent to 1. So basically we just take the remainder of the power. Okay. So the residue of the power mod 6. So that's the reason why I can do this. So we do the same thing for 2. So we have 2 to the power of 2 plus 2 to the power of 3 plus 2 to the power of, so plus 2 to the power of, so let's do it basically. So record that you're adding 7. So the powers are increasing by 7 when you group them like this. So that's equivalent to like the powers increasing by 1 in terms of residue 6. Okay. So this is going to be, it's going to end in 20. So we have 9 plus 6 is 15. So sorry, 9 plus 7 is 16. And then the residue like mod 6, that's 4. Okay. So in fact, you see that this is just going to end in 2 to the power of 2. And then we add again. So 3. So 3 to the power of, so 3 will start with 3. Okay. And so on and so forth. Okay. So basically, let's try to understand how to simplify this on a larger scale. Okay. So we can kind of we can see a pattern coming up here. So the bigger question, so I'm going to pose it this way. The bigger question is something like this. So graph A starts with A to the power of A. Then we have A plus 1, A plus 2, okay, up to A. So recall, we need to understand how many are in each of these big brackets. So recall at the beginning, 2023 divided by 7 gives 289. So in each of these brackets, there are 289 terms. Okay. So 289 times 289 times and so on and so forth. So the bigger picture of what we want to simplify is, okay, so since there are 289 times, it's going to be a to the power of a plus, so 288. Okay, so we need 289 times in this bracket. So I want to simplify this. I want to see how this behaves mode 7. Okay. Okay. So let's simplify this. So this we can factor out a. In fact, we can factor out a to the power of a. So this will be 1 plus a plus a squared plus, okay, a to the power of 288. Okay. What 7? This is sum of geometric progression, sum of GP. So we have a to the power of a. So remember, sum of GP, this is going to be, so let me scroll down a bit. So a to the power of 289 minus 1 divided by a minus 1. Okay, mod 7. Okay, so this is what each of them is going to be mod 7. So we put, so to find the full sum, we just put so we find the sigma from a equals 1 to 7, a to the power of a into 289, 289 minus 1 divided by a minus 1. So this is our final answer. So let's see what it is. So when we plug in 1 into that equation, so we have 1 to the power of 1, 1 to the power of 289 minus 1 all over. Okay, so we see that plugging in 1 here doesn't exactly help. So we find the sum of 1, since each of them is going to be 1 and there are 289 of them. So when we plug in 1, the first bracket is 289. When we plug in 2, so we have 2 to the power of 2, 2 into 2, 2 to the power of 289 minus 1 divided by 2 minus 1, okay, plus 3 to the power of 3 into 3 to the power of 289 minus 1. Okay, so we can actually simplify this. So recall that I spoke about the remainder when it's divided by 6. So I think I'll just apply that here. So 289. So let me just put that here. Let me account for that. So 289 divided by 6. So 6 will go into 28, 4, remainder 4. So 6 will go into 49, 8, remainder 1. So that is just 1. So this is congruent to this sum. So from a equals 1 to 7, e to the power of a to the power of 1 minus a minus 1 over a minus 1. Okay, so what 7? Okay, so a minus 1 will cancel out with a minus 1. Okay, so this is congruent to sum from a equals 1 to 7, a to the power of a. Okay, so I'm going to now erase this. Okay, so this is for when a is not equals to 1, of course. So the first bracket, because we don't want to do the division by 0. So the first bracket is 289. Okay, I think let's just from a equals to, from a equals to. So that makes sense. So 289 plus this. So this is just going to be yeah, congruent to 289 plus this, which is, so 289 is congruent to 1 mod 7. So 1 plus this mod 7. Okay. So 289 rather is congruent to 2 mod 7, not 1. Okay. So this is going to be 2 plus, so 2 to the power of 2 plus 3 to the power of 3 plus 4 to the power of 4 plus 5 to the power of 5 plus 6 to the power of 6 plus 7 to the power of 7. So this is 0. So this is congruent to 2 plus 2 to the power of 2 is 4. 3 to the power of 3, so that's minus 1. So I can just put minus 1. 4 to the power of 4. So that's 256 divided by 7. So 7 will go into, like I just look at it, 4 to the power of 4 is 4 to the power of 2 squared. So 4 squared is 16. So this is 2 squared basically. So which is 4. 5 to the power of 5 is equal to 5 squared times 5 squared. So 5 squared squared times 5. So 5 squared is 25. 25 mod 7 is 4. So 4 squared times 5. 4 squared mod 7 is 2 by 16. So 2 times 5. So that's just going to be 3 because of 10. Then 6 to the power of 6. So recall from Fermat's theorem, this is 1. This is 0. So let me erase this. So hopefully we've not made any mistake in our arithmetic. So we have 2 plus 4 minus 1. So 2 plus 4, 6. Minus 1, 5. Plus 4, 9. Plus 3, 12. Plus 1, 13. Okay. So 13 mod 7. And that's is congruent to, so 6 mod 7. Okay.